So quite a different day here in Advanced Algebra 1. There is no practice worksheet. We're just going to do the first two problems on homework together with technology. So if you're watching this in video land, it's going to be hard to have the homework open and watch the video at the same time unless you use your phone for the video and you got your computer open. You're welcome to just watch what I do on the first two and then go back and do these problems when the video is over with. But here's what we got. We're doing Newton's Law again, guys. Remember Newton's Law from last chapter? But everything was factorable last time, right? Today, not factorable. So here it is. This is an equation of a projectile being thrown. Do you remember which one was the initial velocity? Is it the -16, the 63, or the 155? Which one was the initial velocity? It is the 63. So we'll hit enter on that. I guess you don't need to do that. We'll just kind of wait because what is the initial height then on this bad boy? 155. But what we could do is do algebra to solve for what is the projectile when it was 183 feet high, when did it hit the ground? We could do that. We could also use this graphing calculator that I have programmed into it. So please hang with me because I don't want you to mess up what's called the window of this. Do you see that I have already made the graph go from 0 to 8 and 0 to 275. I did all that work on the back end so you didn't have to figure it out. But here's what we got to do since many people said they have never used desmos before. We've got to go into right here on the left is where we type in the equations. We've got to go in here and click and type in our equation of this guy. It is y equals, then we'll do the -16x squared. So I hit the negative. It was up next to the 0. It's kind of like on your number keys. Are we cool with where the negative was at? -16x squared. You got to use the caret, which is above the 6. It's just kind of like typing answers into my open math, right? So -16x squared. And then can you guys tell me? I have to hit the right arrow button to get out of that exponent. So hit the right arrow. Could you tell me what it was? Plus 63x. Is that what the other one says? Plus 63x. And then plus 155, right? Isn't that the equation that they gave me? Hey, what shape did it make? Parabola that opened which way? Down. So we got that graphed. Then they ask us another question here. You can keep going back and forth between the question and the graph. They say, use the graphing calculator to find when the projectile is 183 feet high. So if it's 183 feet high, we're going to type in a second equation right here. Isn't y the height of this guy, and x is the time in seconds? Remember all that stuff? So we're just going to do y equals, did it say 183 feet? Can you confirm that for me? 183. And it should have graphed a horizontal line. If you're really OCD like me, you could change the color of that if you wanted to by just holding and clicking on this right here. And you could change it to blue if you really wanted to. But you can kind of mess around with Desmos later in that case. We're just kind of rolling with this. But check it out. When they want to know when this is 183 feet high, would you believe that's where this blue line and this red parabola intersect each other at? And if you just click right there, doesn't it tell you where they intersect each other at? So they say round that to 3 decimal places. It's at 0.51 what? 510 or 511? What would you do if you round that to 3 decimal places? 511. But there's a second point. Would you believe that that projectile was 183 feet high at 2 different places? Because it started at 155 feet high, and then it was going up in the air, up in the air, up in the air, and it kept going up, and then doesn't it have to come back down? So it reached that height 2 different times. So we just got to go type those 2 decimals in. 0.511. Let me get back to that. Sorry. 0.511, and could you tell me what the other one was? 0.511, comma. Let's go back to my graph, which I have somewhere. The other one is 3.427. what? 7. So 3.427. So I separated them with the comma, 3.427. And then they say, how long did it take for that bad boy to hit the ground? Well, check it out. Where would that dude be at if I wanted to know where it hit the ground? If you see how I accidentally zoomed that guy out, just be careful. If you pinch and stuff, it zooms this all over the place. I would just try your best to not pinch it. But I have locked the window to where it's at. Where did it hit the ground at? What do you think about right there? Isn't that where it hit the ground at? Click it. does it tell you where it hit the ground at? How long did it take for that to hit the ground? 5.65. We want to go 3 decimal places, so 5.652 seconds. Hey, would you believe that that's very normal? 5.652, is that what we said? Like, to where it didn't happen at exactly 1 second, or exactly 2 seconds, or like 1.5 seconds. It happened in a weird decimally amount of seconds. So submit that bad boy, and we should get it all right. When we get to the next ones, like the first 2 we just do together, I got it to where it'll separate to where you got to put the first one in, you could check it, and then do the second one, you could check it, so all that good stuff. Let's try that one more time. What was the initial velocity of this bad boy? 77. Initial height? 171. Then they say use the graphing calculator, so we'll close out the other one if it was already open. You can just hit this, it'll open a new one. Oh, I guess it's right here already, so I'm going to close that guy out. Yes, I would like to leave it. And then hit the graphing calculator again, and it'll start over with a fresh one for me. So close the old one before we open a new one, the way this is kind of set up. And let's punch our equation in. Y equals negative 16x squared plus 77x plus 171. And the thing you got to make sure is that you have it all typed in right, because I hit plus and I forgot to hit shift, so it actually didn't equals. And then they want to know how long it took for to reach a certain height. What is the height that they give us? 190. So we'll graph that as a second equation. You have to click over here, boom, and click into another guy and do y equals 190. Is that what they said? 190, right? So find those 2 places of intersection and punch them in, right? Punch them in. Round to 3 decimal places. And it looks like we will get, I would like to close that. Just get it out of my way here. Wasn't it 0.261, comma 4.552. I don't think it matters what order you put those guys in or anything like that. But the last question that we got here today is how long until it hit the ground? What do you think? How long until that bad boy hit the ground? If I can click the right thing here. Where did it hit the ground at? Right here, baby. Just click that spot. And how do you feel about 6.46 seconds? Do you notice it says don't put any extraneous answers though, right? So I'll show you one fancy thing that you do not have to put in when you type this. But this is what the graph would really look like. If I use these crazy curly brackets and say x is greater than or equal to 0, close that bracket up, and also say y is greater than or equal to 0. Do you see how I restricted that guy to only be in the first quadrant? Because would you believe you can't have negative time, right? You know, that's not going to go through the ground. You know, yes, it could kind of go underground a little bit, but still, I restricted that. That's why those were called extraneous answers. Because if I get rid of those, would you believe the shape is just a true parabola, and this thing is going to hit like the x-axis somewhere else, but it's in negative land, so we're just getting rid of those. Does that make sense? We're only going to do the positive ones. So here's what we got. You got 2 homework assignments today. I would like you to finish this guy right here. It's just got 3 more graphs on it, then the rest is review. And then when you're done with that, I have a paper review for you so we could test next time. Cool. So let's work together. Let me know if you have any questions.